Today we are going to learn about kruskal wallis test or the H test. In this unit we are having so many tests. Unit 4 is non-parametric. Unit 4 is non-parametric test. Already we know we studied ANOVA tables in statistics and numerical methods. But in that ANOVA table problems, we have some restrictions. The data should be normal and the variance should be equal. So if we don't have that type of restrictions, so how can we calculate or compare the things? So in that case we use non-parametric test. In non-parametric test we have one type of test, that is H test. H test is an extension of U test. In U test we compare only two data. H test is for minimum 3 data and maximum any number of independent data. Here it is a non-parametric test, so no restrictions, like the data should be normal. There are no restrictions over here. Okay. The formula for H test is 12 by n into n plus 1 summation I from 1 to k Ri square by ni minus 3 into n plus 1, where n here is the sample size, total sample size. So here there are 3 samples, so n1 is the sample size of the first sample, n2 is the sample size of second sample, n3 is the sample size of third sample. So when we add all these things we get the value of n, and Ra is the rank. Okay, I will explain everything in the below problem. So the problem is an experiment designed to compare 3 preventative methods against coercion yielded the following maximum depths of pipes of wire subjected to the respective treatments. They give the data. Use the kruskal-wallis test at 5% level of significance to test the null hypothesis that the 3 samples came from identical populations. First of all, we have to use kruskal-wallis test. In most of the problems in this unit, they will give which test we have to use. Otherwise, you have to identify. Here there are 3 data. So for 2 data from different populations, we have to use U test. 3 or more than 3 data, we have to use kruskal-wallis test. Okay, so they give the level of significance as 5% level, and from this problem we have to take the value of n1. Here method A 1, 2, 3, 4, 5, 6. So the value of n1 is 6. Similarly from method B, n2 is 7. n3 is from method C 5. So in the formula we need the value of n. N is nothing but the total sample size, n1 plus n2 plus n3. So that is equal to 18. So first we have to assume that this is our solution H0. They give the 3 samples came from the identical population. So we take the null hypothesis. Null means no, that means there is no difference. So they give that the same thing in the question also. So we are taking H0 null hypothesis as mu1 equal to mu2 equal to mu3. Next we take H1, that means alternative hypothesis, alternative to this null hypothesis. So there is a difference. So that's our assumption. So in the final conclusion we have to select whether H0 or H1. That's our conclusion. Okay. So they give in this problem level of significance alpha equal to 0.05. If they are not mentioning that also, we have to take alpha equal to 0.05. If they mention specifically use 1% level, then we have to specify that value. Otherwise the level of significance is always 0.05. Okay. So this is from our chi-square table. So in your chi-square table, we have to check the degrees of freedom. Here k minus 1, k means number of methods. So here 3 methods overall. So 3 minus 1 is 2. So in the chi-square table, 2 degrees of freedom, 5% level of significance, we get the table value as 5.991. Now we find in the formula, we find n, and table value also we find. Now we have to find the rank values. Okay, so for the rank, write the methods. Now give the rank. For the minimum value, we have to give the ranks in the ascending order. So minimum to maximum. In the total data, 41 is the minimum value, so the rank is 1. So next value is 47, rank is 2. And then next value is 49, rank is 3. And next value is 52, but it comes 2 times, so we have to rank. 2 times means already we give rank up to 3, then 4, 5 ranks are shared by the number 52. So we have to take the average for 4 plus 5 divided by 2, that is 9 divided by 2, that is 4.5. So the rank 4.5 is given to 52. And then now the ranks up to 5 is over. So we have to give from 6. So that is 54, 6. And then likewise you have to give the ranks for other values. Suppose 52 comes 3 times, then the ranks shared by 4, 5, 6. So you have to take the average for 4 plus 5 plus 6 divided by 3. In that way you have to give the ranks for every data. Okay. If some other values repeated, we have to share the ranks like that only. Okay. In that way we have to give all the datas, we have to give ranks. Okay. Now R1 means the rank, sum of the ranks of this column. R2 means sum of the ranks of this column. R3 means sum of the ranks of this column. Add all these things. Now we are going to find the calculated value for H. So formula is 12 by this one. So we write here our n is 18. So 18 plus 1 is 19. Now this summation. So we have 3 R. So first R1 square by the corresponding N1. Okay. So that's why I am writing again here. So from this we can copy this easily. So 84 square by 6 and then 55.5 square by 7 plus 31.5 square by 5 minus 3 into n plus 1 is 19. So calculate this using your scientific calculator carefully. First calculate this bracket value and this one. So use brackets 12 in your calculator. Use like this 12 divided by, you have to use brackets 18 into 19. When there are more than one data, we have to use brackets. Okay, so find this value separately, and for this you have to use the calculator like this. Open a bracket 84 square divided by 6. Close it. Again plus open a bracket 55.5 square divided by 7. Again this one, close it, and then plus 31.5 square divided by 5. Okay. So use like this in your calculator. Use separate brackets, then you will get the exact value. So first find this value separately, multiply that both values, and then the final answer minus 3 into 19. First find 3 into 19 also. Then you will get the exact answer, this one. Now the conclusion is, if the calculated value is less than the table value, we have to accept H0. Otherwise, we have to reject H0. Here calculated value is 6.66, which is greater than our table value 5.991. So we reject our H0. That means what? We are rejecting H0 means we are accepting H1. That means there is a difference. That means the 3 samples are not come from the identical population. That's our final conclusion. Thank you.